geometry students, in this video we will be looking at the three main trigonometric functions known as sine, cosine, and tangent. Now, the other three trig functions are cosecant, secant, and cotangent. We will not be looking at these three trig functions, okay? Those three trig functions, cosecant, secant, and cotangent right here, will be studied more in-depthly in trigonometry in Math 4 or pre-calculus, depending on what you take your senior year. Now, notice the abbreviation for sine looks like sin. It's pronounced sine. This is the abbreviation for cosine. It's pronounced cosine. And this is the abbreviation for tangent. It's pronounced tangent, okay? Alright, your heading for today is trig functions. Please write that down. Lesson 9.5. Your heading for today is trig functions, lesson 9.5, and be sure and include today's date so that your notes are organized, okay? Alright, here we go. Now, let's jump right into this. This information can be confusing, so I need you to push all distractions out of your mind. Pay close attention. Take really good notes, okay? First, let me explain what sine, cosine, and tangent are. Okay, are you ready for this? It's really, really deep, okay? I'm being sarcastic. It's really simple, okay? Write this down. Sine, cosine, and tangent are the ratio of the two sides of a right triangle. So students, I'm going to say that again. When I ask you to find the sine, cosine, or tangent of a given angle, all that you are doing is you are writing the ratio of two sides of a right triangle. Now think how easy that is. If you know which two sides I'm talking about, all you have to do is take one number from one side and put it over the other number from the other side of a triangle. Now guys, that's easy. That's all that these trig functions are. They are the ratio of two sides of a right triangle, okay? Isn't that easy? Sometimes students get so confused about what sine, cosine, and tangent are, but they're just the ratio of two sides of a right triangle. Let me give you the formulas for each trig function so that you will know what two sides I'm talking about, okay? Let me give you the formulas for each trig function so that you will know what two sides go with each trig function. Let me show you what I mean. Copy this down, please. When I ask you to find the sine of a given angle, you put the opposite side over the hypotenuse. Copy that down, please. Now, right now, this is going to sound like Greek to some of you, maybe to all of you. That's okay. Don't worry about it. I'm going to explain this as we go along. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Now I'm going to pause for a second. I'm going to let you get caught up on your notes here. Okay, and copy down these three formulas or these three ratios, okay? You need to know these. And I'm going to show you a really cool way in just a second to memorize these. Alright? So when I ask you to find the sine of an angle, you use opposite over hypotenuse. When I ask you to find the cosine of a given angle, you use adjacent over hypotenuse. When I ask you to find the tangent of a given angle, you use opposite over adjacent. Okay, now, see these first letters right here? S, O, H. Write those down right here. I'm going to show you a really easy way to remember these trig functions, alright? Now, see these three letters here? C, A, H. Write those down. So C-A-H. Now, these three letters here, put them right here. Now, those that had me in 8th grade math 3 years ago, you might remember this. We said a long O, a short A, and a long O, and a short A, okay? So-ka-toa, so-ka-toa. If you can simply remember so-ka-toa, so-ka-toa, then you'll remember that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Okay? Because you need to memorize these, and this makes it a lot easier. Remember, your O's are long, your A's are short. SOHCAHTOA. SOHCAHTOA. Does that help? I hope that it does, okay? You need to know these trig functions, or these trig ratios. Now, having given you these formulas, I need to show you which sides are the opposite, the adjacent, and the hypotenuse. So let me show you what I'm talking about, students, when I say opposite, adjacent, and hypotenuse. Now, all of you know what the hypotenuse is already, so really, I don't need to spend any time on that. However, the opposite and the adjacent, we need to talk about that, okay? So here we go. Let's pretend for a second that I asked you to find the sine, cosine, and tangent of 30 degrees, okay? Alright, now watch this carefully. Let's go ahead and draw our special triangle that we have learned how to draw, that we learned how to draw the other day in class, okay? So I want you to find the sine, cosine, and tangent of 30 degrees. So bear with me. Are you ready? Remember how we did this? Let's review, okay? We draw us an equilateral triangle. Got it? So 60, 60, 60. And we dropped an altitude straight down, remember? And we said all of these sides were 2, 2, and 2. So that means this side here is 2, and this length from here to here is 1. This angle is 60, and this angle here was cut in half. It's 30. So over here, I'm going to trace this triangle right here. So I have this triangle right here. This is 30. This is 60. This is my right angle. This is 2. This is 1. And using Pythagorean's theorem, this is square root of 3. Okay? So I'm asking you to find the sine, cosine, and tangent of what angle? 30. Do you see that okay? Now let's review for a second. Let's relax and let's review. Remember how I told you the sine, cosine, and tangent are nothing more than the ratio of two sides of a right triangle. Got it? So if I'm going to ask you to find the sine, cosine, and tangent of 30, then I better draw a right triangle so that I can look at my sides and find my ratios, okay? So here's my right triangle. Now I'm finding the sine of 30. So in your notes, go ahead and write down sine of 30 equals, okay? Now, what angle am I dealing with? 30. So circle 30. Because I'm dealing with this angle, I go straight across to the opposite side, and I label that opposite. Then I go to my hypotenuse, and I label that hypotenuse. So the only side left has to be my what side? Adjacent side, okay? Sorry guys, let's go over this again. I want to make sure you get this, okay? Now look, what angle are we dealing with? 30, okay? So we circle 30. Then we go straight across to the other side, and we label that opposite. Then we go to the hypotenuse, and we label that hypotenuse. Then we go to the other side, the only side left, we call that adjacent. Now you're thinking, Mr. Earhart, what if you asked us to find the sine, cosine, and tangent of 60? Then these names would move around, you're right. If I would have asked you to find the sine of 60, you go straight across, and now this is your opposite side, and this is your adjacent side. That's why it's so important you circle the angle that we're dealing with. So we're dealing with the sine, cosine, and tangent of what angle? 30. So circle it so you don't forget that, and then go straight across, and that's your opposite side. Then label your hypotenuse and label your adjacent side. Got it? So let's go ahead and find the sine of 30. Are you ready? It's going to be opposite over hypotenuse, so 1 over 2. That's it. You just found the sine of 30 degrees. The sine of 30 degrees is 1 over 2. How do I know that? Because here's the formula. Opposite over hypotenuse. Guys, that's easy. I want you to find the cosine of 30 degrees. Cosine of 30 degrees. Okay? Now come on, think this through. What's the formula for cosine, or the ratio? Adjacent over hypotenuse. Okay? So what's the adjacent side? Square root of 3. What's the hypotenuse side? 2. There you go, you did it. So the cosine of 30 degrees is square root of 3 over 2. Alright, now, sorry about that. Now tangent of 30. Okay, how do I find the tangent of an angle? Opposite over adjacent. It doesn't matter what the angle is. This formula doesn't change over here. It's opposite over adjacent. So my opposite side would be 1, and my adjacent side would be square root of 3. Okay, so are you starting to figure this out, guys? You circle the angle you're dealing with, and then use these three formulas. It's really and truly that simple. Now, there's something I'm not going to stand for or allow in my classes, okay? And that's because really most mathematicians and math books do not let you have square roots in the bottom of a fraction, okay? It's okay to have a square root in the numerator, but it's not okay to have a square root in the denominator. So with that in mind, let me show you what to do when this happens. Before I do that, let's review one more time. Does everybody see where I got the sine, cosine, and tangent of 30 degrees from? I circled my angle because that's the angle I was dealing with. I labeled my opposite side, then my hypotenuse, and my adjacent side, and then I used these three formulas here to help me define the sine, cosine, and tangent of 30, okay? Now, I'm not going to allow you on a test or a quiz to have an answer that has a square root in the denominator. So right now we're going to spend time teaching you how to get rid of these square roots, okay? Remember, students, we're going to take this answer and we're going to simplify it, okay? Now, you can multiply a fraction by anything as long as you do it to the top and the bottom. So what am I trying to get rid of down here? Square root of 3. So I'm going to multiply the top and the bottom by square root of 3. So Mr. Earhart, you're telling us whatever radical you're trying to get rid of, that's what you put here and here. Yes, that's exactly what I'm telling you. So 1 times the square root of 3 is square root of 3. Now watch this carefully. Square root of 3 times square root of 3, multiply your inside numbers, is the square root of 9, and the square root of 9 is just 3. In other words, here's a shortcut for you, okay? Anytime you have a square root times a square root, and they're identical like this, then the answer is just going to be the inside number. So the square root of 3 times the square root of 3 is just 3. The square root of 150 times the square root of 150 is just 150, okay? Now, having established that, some students see this right here, and they're like, yee-haw, and they start just canceling things out. Oh, 3 goes into 3. Listen, guys, you can only reduce numbers that are outside numbers with outside numbers, or inside numbers with inside numbers. For example, if this was square root of 3, and this is an inside number, in other words, it's under the radical, and this is an inside number, then fine, go ahead and reduce them. I have no problem with that. Or, if you've got numbers on the outside, like this, if I had a 6 right here, okay? Well, this 6 is an outside number. In other words, it's not under the radical. This 3 is an outside number. It's not under the radical. So I could reduce those. I have no problem with that. That's totally allowed. That's totally legal. But I don't have 2 outside numbers or 2 inside numbers. I have an inside number here and an outside number here. So please don't reduce those, okay? You cannot do anything with that. So really, the answer I'd like you to put in your notes and on a test or a quiz is that answer there. I don't want you to put this answer here. In most math classes, that's entirely unacceptable, okay? So there we go. So we just found the sine, cosine, and tangent of 30 degrees. Now, listen, you might be thinking to yourself, Mr. Earhart, the sine, cosine, now listen to me, guys. Everybody pay attention and listen to this. You might say, Mr. Earhart, the sine, cosine, and tangent of 30 degrees would be one set of answers for one triangle. But if I had a bigger triangle like this, excuse me for a second. If I had a bigger triangle like this, Mr. Earhart, then the sides would be different. Like this might be 6, and this might be 3, and this over here would be 3, square root of 3. I think, would that be correct? I've got to look this over. I think that's right. So then the answers would be different. No, they wouldn't, guys. Trust me. You get the exact same answers you got right over here. Well, Mr. Earhart, that's impossible because these numbers are bigger. Yeah, but the fractions are going to reduce. For example, if I said to find the cosine of 30, that's adjacent. No, if I said to find the sine of 30, That's opposite over hypotenuse 3 over 6. Well, what is 3 over 6 reduced to? 1 half. What did I get over here for the sine of 30? 1 half. Isn't that cool, guys? It is so cool. And that's basically what you learned the other day. You learned that these triangles, these right triangles, you have one angle here and one angle here. All of your right triangles are going to be similar if they have the same angles, okay? And so it does not matter how big the triangle is. The sine of 30 will always be 1 half, okay? The cosine of 30 will always be square root of 3 over 2. In fact, let's do that over here. Let's go ahead and find the cosine of 30, okay? Cosine of 30 would be adjacent over hypotenuse. So 3 square root of 3 over 6. And now reduce it. This is an outside number. This is an outside number. So 3 goes into both of them. This becomes a 1. This becomes a 2. So you're left with 1 square root of 3, which is the same thing as the square root of 3 over 2. So the cosine of 30 is the square root of 3 over 2. What did I get over here? Same thing. Cosine of 30 is square root of 3 over 2. So, if you were thinking, Mr. Earhart, you can get different answers out for the sine of 30, or cosine of 30, or tangent of 30 if we use different triangles. The answer is no. It's so cool, guys. All of those values will never change, okay? No matter how big the triangle is. And if you thought that, I'm already ahead of this, sorry. If you thought that, all 5 of you that are still awake, I understand why you would say that, but let me show you where you're wrong. And I just showed you, okay? So let's continue on. Now, let's try to find the sine, cosine, and tangent of 45, okay? The sine, cosine, and tangent of 45 degrees, okay? You ready? So here we go. Go ahead and draw your special triangle like I taught you guys how to do the other day. Remember, we learned how to draw a 45, 45, 90 triangle. So here's 45 degrees, here's 90, here's 45 degrees. And guys, by the way, maybe I should have said this earlier to you, but I assumed you understood this. You can only use sine, cosine, and tangent on 90-degree triangles. I would make note of that somewhere in your notes. That's really, really, really important to know. And I should have typed that out and I didn't, and I apologize. So somewhere in your notes, make note of that. The sine, to use sine, cosine, and tangent, you can only use those on right triangles. And that would also be true for cosecant, secant, and cotangent when we get to those later on next year, okay? For you juniors next year. So you can only use sine, cosine, and tangent on right triangles. They will not use on any other triangle. They will not work on any other triangle. So, alright, here's a 45, 45, 90 triangle. Now, remember what we did before? We said the legs have to be congruent because I have 2 congruent angles here. So I called this one, I called this one. Using Pythagorean's theorem, the hypotenuse is square root of 2. This is what we learned on Friday, okay, guys? I hope you guys are listening. I hope you didn't come to class today totally zoned out. You should remember this from Friday's video, okay? If you missed Friday for whatever reason and you came to class today totally unprepared, not having watched the video, it's not smart, guys, okay? When you come into this class, you're to totally be caught up, okay? Alright, so now I can quickly find the sine, cosine, and tangent of what angle? 45 degrees. This should be pretty simple to do. First of all, what angle am I dealing with? 45. So circle it. Well, Mr. Earhart, I circled this one down here. It doesn't matter. Just circle one of them. You'll still get the same answer. Circle 45. Go straight across to the opposite side. This is your opposite side. Go to the hypotenuse and label it hypotenuse. Go to the last side left over. Label that adjacent. Okay? So sine is opposite over hypotenuse. So opposite is 1. Hypotenuse is square root of 2. Now that answer is no good because I have a radical in the denominator. So I'm going to come down here and rationalize it. That's what you call this process right here. We call it rationalizing the denominator. So I'm going to multiply the top and the bottom by the square root of 2. 1 times the square root of 2 is the square root of 2. Square root of 2 times square root of 2 is 2. Don't reduce these numbers. This is an inside number. This is an outside number. So, sine of 45 is square root of 2 over 2. Now, let's find the cosine of 45, okay? That would be adjacent over hypotenuse. So here's adjacent, here's hypotenuse. Look, it's the exact same thing. 1 over square root of 2. So let's rationalize that, which we already did down here, and we'll get square root of 2 over 2, okay? And now the tangent of 45. Well, tangent is opposite over adjacent. TOA, opposite over adjacent. 1 over 1, which is 1. So there we go, we did it. So the sine of 45 is square root of 2 over 2. The cosine of 45 is the square root of 2 over 2. And the tangent of 45 is 1. Okay? There we go, guys. We're doing really, really well. Okay? Alright, let's continue on. Now, let's try to find the sine, cosine, and tangent of an angle that you don't know the measure of. That sounds interesting, okay? Let's take a look at this. Let's try to find the sine, cosine, and tangent of an angle that we don't know what the angle is. Alright? So please take some really, really good notes on this. Copy this triangle down, please, okay? Copy that down. Alright? So I've got a right triangle, triangle TRS. Copy that in your notes, please. Right angle's T. This angle up here is R. This angle's S. And the lengths are 5, 12, and 13. 5, 12, and 13. Copy this down in your notes, please. Next, we're going to find the sine, cosine, and tangent. Oh, my bad. I'm getting ahead of myself. There we go. So go ahead and copy this down, please. Now, we're going to find let's start off by finding the sine of S. Can we do that, please? Let's find the sine of angle S. Okay, so what angle are we dealing with? S. So come over here and circle S. Got it. Now go straight across. This is your opposite side. Go to your hypotenuse. This is your hypotenuse. So the only side left over is your adjacent side. Got it? Okay, so the sine is opposite over hypotenuse. So the sine of S is 5/13. Pretty cool. Alright, let's find the cosine of S. The cosine of S. Alright, well, the trig ratio for cosine is adjacent over hypotenuse. So adjacent 12 over hypotenuse 13. So 12 over 13. Now, let's switch gears for a second. Let's find the tangent of R. The tangent of angle R. So now we're no longer dealing with S, are we? So we better erase all this stuff here. Alright? And now let's go ahead and circle R. So, draw a line straight across. This is going to be your opposite side. This will still be my hypotenuse, and the last side left over is your adjacent side. So there we go. What is the trig ratio for tangent? Opposite over adjacent. Opposite over adjacent. Don't forget, guys, you can learn this very quickly by so, ka, toa. Alright? So the tangent of R is opposite over adjacent, 12 over 5. So students, sometimes you don't even have to know what the angle is, like 30 degrees or 50 degrees or 60 degrees, whatever. You don't have to know that. As long as you have a right triangle with all of the sides labeled, and you know what vertex you're referring to, you can still find the sine or cosine or tangent of R, or the sine, cosine, or tangent of S. Now, we're never going to find the sine, cosine, or tangent of a right angle. Now, in trigonometry, we do. Okay, in pre-calculus, in Math 4 class, next year for you seniors, we get into that. We get into this a lot more deeply than we are in geometry, okay? But understand that we'll only be finding the sine, cosine, and tangent of these acute angles right here. Never, not never, the right angle. Now, do you see how to do this? So you circle the angle you're dealing with, label your three sides, then write your trig ratio. It's really pretty simple, okay? Now, next, let's find the sine, cosine, and tangent of angles without having a triangle at all. Now, to do this, we're going to have to use your calculators. So you guys really should already bring your calculators to class every day. Every day when you come to class, you should have your books, your notebooks, pens, pencils, calculators, and be ready to work, okay? Textbook, of course. Also, is make sure everyone's calculator is in degrees and not radians. So let's take care of this. First of all, a lot of you students have a graphing calculator. A lot of you do. And I call these graphing calculators, I just simply call them graphers. So that's what I'm going to call them, okay? So if you have a grapher, listen to me very carefully, alright? Remember, columns go up and down like this, okay? Rows go across like this, alright? So if you have a graphing calculator, a grapher, I want you to, here's your graphing calculator right here. Here's your screen right here. I want you to go to the second column, so 1, 2, go to this column right here, and look at the top button right here. It should say mode. Okay, push that. Now when you push mode, well, it would help if you turn your calculator on first, okay, obviously. So turn your calculator on, then push mode, okay? Now if you'll go down 3 rows, you're going to see radians and degrees. Make sure degrees is highlighted. Now if radians is highlighted, okay, if radians is highlighted, no big deal. No big deal at all. Just scroll down to radians and then move it over to the right. So with your right arrow, move it over and then hit enter on degrees. And now degrees is highlighted, okay? After you've done that, please listen carefully. Right beside the mode button right here is your shift button or your second button, okay? To come out of this mode, you hit second and then mode, because right above mode is the word quit. So anytime you want to quit something on your calculator, on this grapher, you hit second and then mode, which really means quit. So hit second mode, and now you're in degrees, okay? Alright, now for others of you that don't have a grapher, you understand that I've seen a million calculators in my about 20 years of teaching, a little less than 20 years, and I can usually 99.9% of the time show you exactly what to do, but I would have to be there to do that, okay? So do the best you can. Some of the buttons will say something like, they'll have like a D and a double arrow and an R, degrees to radians. Sometimes in the screen you'll see a D or an R, and one of those will be, it'll either have a D in the window or an R up here. It'll have a D or an R depending what mode you're in. Okay, you're going to have to figure that out. Ask for some help. If you need to email me and send me a picture of your calculator with your phones or whatever, I can get back with you and show you how to make sure you're in degrees. Now some of you might already be in degrees, okay? So the only way to find out is to work a problem and see if you get the right answer, okay? So let's go ahead and try one of these. I want us to find the sine of 35. So with your calculator, if you have a grapher, I want you to push your sine button. Now your sine button is your second column from the left. So not this column, but this column right here, okay? Here's your screen right here. And then go down to the fourth button. 1, 2, 3. Fourth button right here. It should say sine, okay? So you push sine, and if you push sine on your screen, this will pop up. Then type in 35. You do not have to close the parentheses. You do not, okay? Don't worry about that. Just hit 35, then hit enter. And you should get this answer right here. If you're in degrees, you will get this. 0.5736. I rounded that. It really says 0.5735764364. I rounded to 4 decimal places, okay? Now, if you type this in, now some of you, by the way, if it's not working, if it's saying error, some calculators want you to type in 35 first and then hit the sine button. So try that and see if that works, okay? You've got to get to know your calculator, okay? Better than you know your girlfriend or boyfriend, alright? Just kidding, but you get the point. Make sure you know how to use these, okay? So, if you're not getting this, let me tell you what you're going to get if you're in radians. If you're in radians, you're getting this right here. You're getting negative 0.4281. So if you're getting negative 0.428182, etc., you're in radians, and you're going to have to get help from someone and find out how to get into degrees, okay? Alright, let's try another one. Everyone, if you guys got to pause this video and get help from friends, everyone needs to know how to do this. It's really, really important, okay? Let's find the cosine of 10 degrees. So with your calculator, some of you are going to put 10 in first and then hit cosine. Others of you will hit cosine first and then 10, okay? The cosine of 10 degrees is 0.9848. If you rounded, 0.9848077753. That's the cosine of 10 degrees. See, your calculator will do this for you. You don't even need a triangle sometimes, okay? But of course, we need to know how to do this all different ways. Alright, now let's try this. Let's try the tangent of 74. So some of you will hit 74 first, and then tangent. Others will hit tangent, and then 74, okay? Either way, you'll get this answer here if you're in degrees. 3.4874144444. So students, please, if you're having trouble with this, email me a picture of your calculator. Talk to Miss Walker, okay? I mean, she will, without any doubt, be able to show you how to get your calculator into degrees, and also she'll show you how to type this into your calculator, whether you type 74 first, or tangent first, or whatever the problem might be. See her. Mr. Hamill could help you, or Mrs. Huguenin. I'm kidding on the last one, but anyways, you get the point. So, alright, let's continue on. Lastly, let's finish up with a favorite of all students. No cheering allowed. Word problems, okay? Let's try a word problem. Now, in your notes, I would not try to copy this whole problem down. Don't do that. Just simply write this in your notes. Go ahead and copy this down, please. Page 456, example number 4. Now, if you want to open your books, you can. If you just want to take notes, that's sufficient. You don't have to open your books if you don't want to, okay? But we're going to look at page 456, example number 4. Actually, I stand corrected. For this problem here, I do want your books open. So I'm going to pause a second while you guys turn to page 456, and we look at example number 4, okay? Page 456, example number 4. Okay, go ahead and open your books, please, and here we go. And the reason I want your books open is you're going to see the overhead projectors right here. It has a screen coming up and all of that type of thing. And there's an angle formed. I want you to see that in your book, okay? That's why it's very important that you have your books open, please. Alright, you are using an overhead projector. That is if you're teaching back in the 1980s, okay? So overhead projector to show a horizontal bar graph as shown in the diagram below. Find the distances from the projector to the bottom of the screen to the top of the screen. So here is your overhead projector right here, like you see in your book. And my skills, I know my drawing skills are just nothing short of amazing. And here's the screen over here. Here's the top of the screen. Here's the bottom of the screen over here, okay? This looks more like a golf hole in golf with a flag, and there's the hole for the golf ball. That's pathetic. Anyways, so if you'll look in your book, you're going to see a drawing much inferior to my drawing, and you're going to see that we're trying to find the distance from the projector to the top of the screen, that red line there, and we're going to try to find the distance from the projector to the bottom of the screen, so this line right here. Now this is not going to be easy to do, so please listen carefully and let me help you, okay? Now, first of all, notice we have a right triangle. Second of all, notice we're missing two sides. 1, 2. I mean, man, doggone it. If we knew two sides, we could use Pythagorean's theorem and find the third side. Or, remember, if we had one of our special triangles, remember our special triangles, 45, 45, 90, 30, 60, 90, if we had one of those, and you know one side, you can find the other two sides, but we don't, guys. We have a 35, 90, 55 triangle, okay? So that's not going to help us. So we can't use Pythagorean's theorem. We can't use our special triangles. So how are we going to find the length of r and x? Well, I'm glad you asked that question. We are going to use trig ratios. Watch carefully. This is nothing short of cool, alright? Now, we're dealing with 35 degrees. Mr. Earhart, how do you know that? angle. So this is my hypotenuse, okay? And this is my adjacent side. Got it? Now, guys, think of your trig functions. Are you ready? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Got it? Tangent is opposite over adjacent. Now I have a question for you. Which side do we know? Do we know the hypotenuse? No. Do we know the adjacent? No. Do we know the opposite? Yes. So why in the world would I use cosine? I mean, look, the two sides are what? Adjacent and what? Hypotenuse. That, guys, that's two unknowns. That's an r and an x. Well, that's not going to help me. I don't want to have an equation with two unknowns. So don't use cosine. We're going to use sine. Because look what I have right here. Opposite. And I know the opposite's 4. Look what I have right here. Opposite. And opposite is 4. So I'm trying to use trig functions in which I have one of the sides known. Now, let's go ahead and start with sine, okay? Please watch this carefully. Sine of 35 degrees equals what? Now come on, guys, figure this out. The sine of 35 is what? Opposite over hypotenuse, correct? In other words, the sine of 35 is 4 over what? R. Do you see that? Look at it again, guys. The sine of 35 degrees is opposite over hypotenuse, 4 over R. Now, let's solve this equation. Mr. Earhart, you can't, this is crazy. Hold on, guys, hold on. We know what the sine of 35 is. We do. Yeah, you do. Get your calculator out and type it in real quick, okay? So get out your calculator and type in the sine of 45 degrees. Sine of 45, hit enter. We're going to round to 4 decimal places. So 0.7071 equals 4 over R. See, guys, look, you have nothing to fear. This is nothing more than a number. That's all that it is. So type into your calculator. So the sine of 35 is 0.7071. Now, remember from Algebra 1 and Algebra 2, if you're trying to solve for R and it's in the denominator, multiply both sides by R because you want to get rid of your fraction. Whatever your denominator is, you multiply both sides by your denominator. Now, if the R was up here and the 4 was down here, then what's your denominator? 4. So you would multiply both sides by what? 4. Whatever your denominator is, you multiply both sides by your denominator. So if I multiply this side by R, I get 0.7071 R. Okay? If I multiply this by R, well, think about it. 4 over R times R over 1. Your R's cancel. You're just left with 4. That's the whole reason you multiplied by R, was to get rid of your fraction. So if I multiply this side by R, I get this right here. If I multiply this side by R, I get 4. Now you know how to solve this. Divide both sides by what? 0.7071. These cancel, and R equals, let me get out my calculator here real quick. Okay, students, I'm back, and let's make a quick change here. I think that your old teacher hit a wrong number on his calculator. I typed in the sine of 45, and so I apologize. We're looking at the sine of 35. Let me type that in again, please. You guys are wondering where I got that. Okay, does this look a lot better? How about this? 0.5736. I rounded that, okay? Now, multiply both sides by R. 0.5736 R equals 4. Now divide both sides by 0.5736. So with your calculator, type in 4 divided by 0.5736. If you do that correctly, you're going to get 6.97. So I'm going to round that to 7. So there's the length of R. R is 7. Pretty cool. So we use sine. Now we're going to use tangent to find x, okay? So here we go. You can work ahead or watch me. Here we go. Tangent of what angle? 35. equals what? What does tangent equal? Opposite over adjacent. So opposite over adjacent, 4 over x. Now remember, tangent of 35 is nothing more than a number. So if you type in tangent of 35, and I'll try to do it right this time, you're going to get 0.70002 equals 4 over x. Now, what is your denominator? X. Multiply both sides by x. Multiply this side by x, and you get 0.70002x. Multiply the right side by x, and you get 4. Now divide both sides by 0.7002, and you're going to get 5.71259227, or something close to that, okay? You might be off a little bit, but you should get 5.7 for your answer if you round correctly. So x equals 5.7. That's a really good word problem, guys. So as you can see, we're getting into some good, challenging math, and a lot of you have kind of cruised this year and found geometry to be, some of you have found it to be pretty difficult, others have found it to be pretty easy. I think in this chapter here you're going to learn a lot of stuff, okay, and be challenged with some pretty interesting math, okay? Alright, I hope this video has been a help to you. If you have any questions, don't hesitate to call or email.